so scared. Today I'm having a calculus exam. Oh, I'm really nervous. Thank God I can use my calculator. Without this, I'd fail. Oh, geez. Hey, my calculator. It's not turning on. You broke it.
Let me see. Huh. I think I know what's wrong with it.
How do you know?
I took an engineering class, 1100.
Can you fix it?
Seems like something's wrong with the current and the voltage. The wires seem to be misplaced. Yeah, I think I can fix this. Good thing I have my handy dandy screwdriver with me.
So for this question, we're going to be using the engineering method, and let's start off with the first two steps. For step 1, we want to recognize and understand the problem. Our problem being that we need the current of Ix and the voltage across the current source in order to fix a calculator. Here we have a basic diagram of our circuit. This is what we're going to be needing later on to solve for the current and the voltage. For step 2, we're going to accumulate data and verify accuracy, and we're going to do that with our circuit diagram. So here we have all our data. Let's start off with the resistors. For resistor 1, it's 250 ohms. Resistor 2 is 150 ohms. Resistor 3 is 200. Resistor 4 is 350 ohms. For voltages, voltage 1 is going to be 12 volts. Voltage 2 is going to be 10 volts. And voltage at the unknown source is what we're solving for. Our currents consist of Ix and Iy, which are unknown, and Is at the source, which is 120 milliamps.
Now we know that the first two steps for the problem. Now we need to find equations and theories that will allow us to solve for this problem. And in this case, the three main ones that we will be using is KCL, KVL, and Ohm's law. And in this case, KCL is all the current going towards the point minus the current going away from the point. So in this case, all the currents appear to go towards one point. So it would be Ix plus Iy plus 120 milliamps is all equal to 0. And also, that's not only the only equation, but there's also the dependent variable for this equation. It should be negative Ix minus Iy minus 120 milliamps is equal to 0. So this is the equation we will have for KCL. So now that we have done the first three steps, now we are on the fourth step, which is assumptions. And in this case, one assumption we can have is that this circuit is completely closed. It's a closed circuit, and it doesn't leave any gaps open at all. Another assumption we can have is that the battery doesn't begin to decay, which means the voltage, it stays constant at 12 and it wouldn't change anything else, no matter how, which also goes into our third point. No heat is given off, because that's how a battery tends to die out. It's because when a voltage keeps pushing through all these pushing through the circuit, it begins to give off heat, which then starts to lose its voltage, which makes it start to die out. And these are the three main assumptions.
For step 5 of the engineering method, we'll begin to solve the circuit. First, we'll begin by notating and assigning the polarities. We'll mark our voltages down as V1 and V2. Then we'll assign our current its own unique notation. Then we assign each of our resistors both a R and a V for their respective voltages, and then we'll assign polarities. For this, we'll use passive sign convention. Therefore, R1 is being opposed, 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 and opposed to all of their currents. For part 2, we'll find our KVL and KCL equations. First, we'll find our KCL at point A, as shown here. Then, using the loop rule for loop 1, we'll find the equation 2. We'll find the same thing for equation 3 at loop 2, and then once more, the final fourth equation at the outer loop for loop 3. Then we'll begin to solve for Ix using equation 1 and 4. We can isolate Iy and then plug in each of the known values into there. Our known values being R1, V1, R2, and V2, and R3. Once all those values are plugged in, we solve and isolate for Iy once more, and we'll get a resultant equation for Iy. Then we plug in Iy back into our Ix equation, equation 1, and we'll solve by combining and collecting all the terms as the values we know. Then, once we find Ix, we'll simply isolate and solve and get our value. For the second part, for finding Vs, we use equation 2 and simply set Vs equal to everything. Because Vs is positive, when we put it at the other side, it will become negative, so we switch the signs of everything on the other side. Then we plug in our knowns, being V1, Ix, R2, I1, R4, Ix, and R1. For step 6, verify. The circuit has been modeled here in this theoretical circuit builder. We can see that indeed the current flowing in the resistor R1 is in fact negative 21.33 milliamperes, just as our calculation showed. Furthermore, in the voltage for the current source, Vs is also calculated at 48.80 volts.
All right, and that should do it.
Does it work now?
Let's find out. 2 plus 2 is 4. Yep, you're good to go.
Oh, thank God. Thank you.
Of course.
Now I can pass my calculus exam.
Yeah.